طيب بسم الله الرحمن الرحيم. So we started last time the wireless security standard part. As we said, the chapter is divided into 3 parts. In part 1, we talk about the properties of wireless that makes wireless eligible for special treatment when it comes to security. We talked about many of these properties. In the second part, we reviewed the wireless architecture. We talked about basic service set and extended service set and the main architecture and what are the terminology that we use, the concept of association, reassociation, and deassociation, and so on. In the third part, we just introduced some high-level description of the wireless security standards. So it started with WEP, or Wired Equivalent Privacy, and that one was very weak from all aspects because it uses one pre-shared key for all the BSS. So it's one pre-shared key that the access point shares with all the stations. So this is used by all the stations to communicate with the access point, and by access point to communicate with all the stations. And the only dynamic part, as we said, is the initial vector, which the access point uses to create dynamic keys that it changes that pre-shared key over time. But again, every time it's changed, it gets shared amongst all the stations. WPA, or Wi-Fi Protected Access, tried to strengthen this a little bit. So we tried to have, and again, this pre-shared key is only dependent on the passphrase or the password. So the password that you configure in the access point, you use that password to generate a pre-shared key. Very simple. And that's what makes this approach very breakable. Not only that, for encryption, we use RCA, we use Stream Cipher, which uses XOR, simple XOR. So you use the password to generate a random sequence, and then the random sequence, you XOR it with the incoming stream. Very simple. So from security perspective, this is weak. Okay? So you can really detect or do some crypto analysis to get the password easily. And there are some tools out there that allows you to do this. So the fact that this pre-shared key is shared with all the stations, all of them, it makes you able to just get any kind of dongle and use the same shared key, and you can send the station any kind of packet and get the response, and you expect what the response would look like. So by knowing the one data and one cipher text, you can XOR them and get the key. So the protected access here, or WPA, was done through some software updates. It's a patch that you can add to the access point. And this patch, what it does is that it uses a combination of the password and the MAC address of the station. So it's actually now, it's different for each station. Okay? So the fact that this is different for each station makes it a little bit more protected. But still, it's still breakable. But compared to WEP, this is a good improvement, and it only requires some software patch. So you don't have to change the hardware of the access point.
In Wi-Fi protection, we use symmetric or asymmetric encryption?
We use symmetric. We use symmetric. WPA, of course, changed only the authentication part. And instead of using one pre-shared key for all the stations, now we use the key as a function of both the password, okay, and the MAC address of each station. So that makes it different for each station. Okay? So the attack surface is really narrowed down. So the possibility of attack now becomes much smaller, but still it is breakable. The encryption part is done through normal RC4. There is no change in that regard, which again makes it also prone to attacks because, again, RC4 is not good from a security perspective. Because, again, it's based on Vernam cipher. It's based on XOR. You generate the key sequence and then you XOR it with the incoming sequence. That's it. Okay? And we said that from a security, it's good from error resistance point of view, but it's not good from a security perspective.
But error resistant because it's encrypted by
No, because it XORs the random stream with the incoming stream. So if there is any small error, okay, the error will be localized. يعني مثلا if you transfer this stream over the network and then use مثلا UDP ولا the channel introduces some error, the error effect will be localized. Imagine بقى if you do block cipher. Block cipher, if there's one bit in error, the whole block will be in error, right? Because it's not based on simple XOR. Only one bit will make the entire block unusable. Okay? So the larger the block is, like for the case of AES, it makes the error propagate in a big chunk of the data. So this will make the whole data not usable and it's corrupted. Okay? So those two, they don't use any kind of block cipher, they use only RC4 as a stream cipher. The problem with stream cipher as RC4 is that it is not good from a security perspective. So RSN بقى introduces major fundamental change, as we said. RSN is the same like 802.11i. And pay attention to the terminology, because now we're talking about so many things. And today, actually, we'll talk about so many terminology. So 802.11i is RSN, is WPA2. All of them refer to the same thing. Okay? So 802.11i is equivalent to RSN, is equivalent to WPA2. This is WPA1. Okay? RSN came up with two major fundamental changes. One is on the authentication part. The authentication part is not done using password only. No. It's done using 802.1x. Remember in network access security? So you have to go back through the authentication server using the radius, and you have to use one of the possible authentication methods, whether IKE or TLS or TTLS, similar to what we discussed in previous chapter, which of course you don't remember. Okay? This is on the authentication part. The result of this command will be a master key, and from the master key we have to use another level of complexity. We generate multiple keys from this master key. And then on the encryption part, we use more complicated, not simply RC4. We use encryption using what we call counter mode AES. So we use block cipher, which is good from a security perspective. However, we use counter mode operation with AES. Counter mode kind of flips or transitions AES to have a stream cipher behavior. Okay? We did not study this in details. But it converts or transforms the block cipher into a stream cipher behavior. So this way we can gain on the security part, but again still makes the stream more error resistant. Okay? But this requires hardware changes. So you have to remove the access point and replace it completely. ماشي كده؟ طيب. So this is the high-level services that are provided by RSN. So starting from here, forget about WEP, forget about WPA. We'll discuss only WPA2 or RSN. So we'll discuss اللي هو 802.11i. This is what we are going to focus on. So 802.11i provides access control using اللي هو 802.1x. So it uses 802.1x. اللي هو port based. Here the port is logical port, right? We talked about wired control access security, right? And we said that we provide controlled port through 802.11 صح? We talked about this, and we use that to provide a control port, and this port is authenticated, and we can use it for communication. Now, we have also studied the extensible authentication protocol. Extensible authentication protocol provides a unified interface to perform authentication against authentication server, or using radius. ماشي? We'll see this graphically now. So now, as we said, EAP provides a transport layer service for conducting the authentication, right? And 802.1x provides access control service for providing the authentication process. ماشي كده؟ طيب. So EAP on top of 802.1x, they can be used to exchange messages to do the authentication. So this is number one, and this is number two. Type. Once we do this authentication, the result here will be master session key. So we have master session key based on this authentication process. From this master session key, we will see that we will generate other keys بقى. Many other keys. يعني في طفح من الكيز دلوقتي هيظهر. You have to really pay attention and really be able to define what each key is used for. ماشي? You have to really pay attention to this. From this master key, we will have a key generation method, which will allow us to generate multiple keys. Okay? These keys بقى will be used for confidentiality and for message authentication codes, message authentication, not user authentication, message authentication. Okay, and for non-repudiation. So MAC is used for integrity and non-repudiation, and of course we have confidentiality, right? Type. For this, we have two ways. We have what we call TKIP, or Temporal Key Integrity Protocol. Temporal Key Integrity Protocol uses RC4. هتقول لي الله احنا we got rid of RC4. We still keep it in WPA2 for ايه بقى؟ For backward compatibility. ماشي؟ واحنا every new standard we have to make it backward. يعني انت افرض انت جبت access point بس انا I want to use the old method، انا حر. ماشي كده؟ and I want to use a simple mechanism. That's why in access points here, when you open, you see many choices, right? One of them is WEP, WPA, and WPA2. So TKIP here still uses RC4 for backward compatibility. So in that case, RC4 is used for confidentiality, right? But of course, as we said, from a security perspective, this is not secure enough. If you want to go with it, okay, it's your responsibility. But we provide another alternative which is more secure. This is a counter mode Cipher blockchaining MAC protocol. And counter mode with Cipher blockchaining MAC protocol. As we said, we provide confidentiality, and we provide اللي هو الايه؟ الماك, right? We provide confidentiality and we provide message authentication codes. Message authentication codes فاكرين عشان ايه ولا مش فاكرين؟ To authenticate each message that it's coming from the right source so that we can mitigate man-in-the-middle attack. Okay? If we don't do this, anyone can send us any data and we can accept it. لا, احنا before we accept any message from anyone, we have to authenticate that it's coming from the right source. Okay? And we talked about approaches to do this using اللي هو ال HMAC والاشياء. ماشي؟ طيب, here we are using different methods for confidentiality and different method for MAC or message authentication codes. Sometimes here they refer to this as message integrity codes. So MIC or MAC, they are the same. ماشي? Just not to be confused. So here in the standards, in many ways, sometimes they refer to MIC or MAC. ماشي? Again, this is used for message authentication and non-repudiation. كويس? Confidentiality is for encryption and decryption of the message itself. ماشي؟ طيب, for encryption, as we said, we have an incoming stream, and then we encrypt it to become a cipher stream, and then we send it. Okay? The good thing about RC4 is that it's good, it's error resistant, okay? Which means that if an error happens, it's localized, but it's not strong, it's not secure. It's not very secure. Yeah. ماشي? So that's why we use what we call counter mode with AS. So we use AS and counter mode for confidentiality, for encryption and decryption of the data itself, right? ماشي? So this way we achieve both benefits. We make it secure, more secure compared to RC4, and we still preserve the error resistance. ماشي كده؟ With counter mode AS, we have the two benefits. Okay? Of course, it's more complex, but it has the two benefits. It has the error resistance and it is secure. ماشي? I can explain briefly how the counter mode works. It's very simple, but يعني it's not that important. It's not that important, يعني. But it's enough to know that the counter mode with AES combines the two benefits of having a stream cipher behavior in terms of error resistance, and at the same time it's secure. ماشي? So confidentiality is done using counter mode with AES. When it comes to MAC, I'm not encrypting a stream anymore, صح? MAC is done for integrity, not for confidentiality. So I don't really care about the cipher stream behavior. In that case, بقى, I care more about being secure without having to have error resistance. I don't care about error resistance. So in that case, MAC, they use what we call cipher block chaining, also with AES. Cipher block chaining is really highly secure, but it does not provide stream cipher behavior anymore. ماشي? Which means that if there is any slight error in the MAC, okay, the whole thing is an error. But that's fine, because if there is any small bit in error in the MAC, I cannot authenticate the message and I will throw it away anyway, صح? So it's fine. Okay? I don't need to have cipher stream behavior for MAC. I don't need to have this. أنا بقول لك بس what is the rationale behind why the standard uses a specific method for confidentiality or for MAC. ماشي كده؟ Okay? So I can explain briefly. Again, this is not يعني if you don't get this 100%, it's fine. So what happens is that what we do is that if we have data like this, for block ciphers, what do? We divide it into blocks, right? And then we take each block, we apply AES, and then we take the cipher, and then we send it, right? If we try to use counter mode, we will not do this. Okay? Instead, we will take this as a stream. Okay? But then we want to use AES because AES is secure. Okay. So instead of doing this, what we will do is that we will not do this. We will not encrypt the actual block. We will encrypt a counter. That's why it's called a counter mode. Counter معناه إيه؟ counter. You encrypt 1, 2, 3, 4, 5, 6. Okay? Any kind of counter. Okay? And you will keep encrypting counters like this. طبعا الcounter every time changes. Okay? So the result will be cipher counter. Okay? And then we XOR it with the incoming stream. So it's like you are using counter mode with AES to generate a random sequence similar to the fact that we use it for RC4. Okay? And then you XOR with the incoming stream and so on.
The counter will be with nonce or without?
لا counter is without nonce.
In computer security, the counter mode will be with nonce. The nonce will be fixed and the counter change after we encrypt like.
لا, if the nonce is fixed, ما هو خلاص, if the nonce is fixed, the whole counter is fixed. يعني مش not fixed معناها ان هو the counter increments every time. فانت you have مثلا the nonce is like you start from an initial count. ما هو انت you don't start from zero. You start from, let's say, 1 million. ماشي 1 million, 1 million and 1, 1 million and 2, 1 million and 3. That's fine. So if the nonce is fixed, it's the same. يعني خلاص. كأنك يعني you start from a specific count. Doesn't matter where you start from. ماشي. So instead of encrypting the block, you encrypt a counter and then you use the result to XOR with the incoming stream. ماشي. So this gives you a cipher stream-like behavior, صح? But you are not really generating by random sequence using the normal method of RC4. لا, you are using a more complicated method by encrypting the counter using AES. And we know AES is highly secure. ماشي? So by doing this, we strengthen the security part. Okay? طيب, ايه بقى cipher blockchaining ده? Cipher blockchaining بقى does not do this. Cipher blockchaining tries to make the security the maximum. What it does is that not only بقى it takes one block of data and then it encrypts it using AES, okay? No, what happens is that you take one block, you encrypt it using AES, okay? And then the result will be the ciphertext. You XOR this using some initial vector, and the result will be the input of, not like this. The result will be XORed with the result from the next one. Okay? And then you take this, and then you put it as an input for the next one, and so on. Okay? So for this one, by the way, if there is one single error, it will propagate in the entire stream. So this is highly irresistible to errors. ماشي? This is the opposite of the RC4 or the counter mode. This is the opposite. Okay? But the rationale behind using this, because it's highly secure. Why? Because you can only decrypt if you follow the same chaining of blocks. ماشي? If you're not following the same chaining of blocks, you will not be able to decrypt correctly. So even if you start from somewhere, if you don't have the previous chaining history, you will not be able to decrypt anymore. So this is highly secure, but the bad thing is that it's highly irresistible to errors. Okay? But this is good for the Mac. Why? Because for Mac, we don't, بالعكس, for Mac, if there is one bit in error, we cannot do anything anyway. We have to throw the whole thing because we cannot authenticate the message, in which case we have to throw the message anyway. That's why a method like this is attractive for Mac. It's not attractive for encrypting the data because it's highly irresistible to errors. But this is good compromise for encrypting the actual data. ماشي كده؟ So that's why here the standard talks about using two different methods. Counter mode for confidentiality, ماشي? Because confidentiality معناها we should encrypt the actual data. And cipher blockchaining for MAC or from MIC or for message integrity codes. ماشي? Because this is highly secure and we don't need to have stream cipher behavior. We don't need to have this. ماشي كده؟ But then we still have TCAP اللي هو ال temporal key ده. Why? For backward compatibility only. Because WPA2 needs to be backward compatible with WPA1 and WEP. واضح كده؟ ماشي؟ فin terms of authentication for access point, we can have possible ways, some possible ways. يعني one way is to do a no authentication. خلاص. I don't need password. I don't need anything. Everything is open. Okay. There's no key أصلا. There's no encryption. There's nothing. أنا حر. ماشي. ماشي. This is the primitive way. Or I use WEP. ماشي. That's why if you look at the wireless routers, you will see a list box. One of them is none. WEP, you're like, what is the password? ماشي? WPA, you need the password also. But WPA combines the password with the MAC. So it's the key is different for each station. So not only is it different through time using initial vectors, but it's different over time and for each station using the MAC address of the station and the MAC address of the access point. We talked about this last time. ماشي كده؟ But again, the encryption and everything is done using RC4, which is not really secure. Or the last option is WPA2 or 802.11i or RSN. In all of these are the name for the same thing. And for that case, we have to do authentication using 802.1x and extensible authentication protocols through radius server, and we have to go back and forth. And this is what we are going to talk about in the next slide. You will see how many keys do we have to generate in that case. This is very, very complicated. Okay? So confidentiality. So for confidentiality, as we said, we have the TCAP using RC4, or we have the counter mode. Counter mode with AES. As we said, ماشي؟ طيب for integrity طبعا we use the TCAP, also using RC4. We use the TCAP to again encrypt, but for this case we use it for message integrity codes, ماشي؟ Or we use HMAC MD5 or we use HMAC SHA1. If you go back to chapter 4, you will see these methods are used a lot for message authentication codes. ماشي؟ Or we can use Cipher blockchaining with AES. اللي هو Cipher blockchaining with AES. If you go again to chapter 4, you will see that we can generate MAC either using encryption techniques or using hashing techniques. ماشي؟ So these methods use hashing techniques. ماشي؟ Or we can use the encryption techniques using AES, but in that case we can use Cipher blockchaining to make it more secure. ماشي؟ تمام؟ Then خلاص the result from these two. So before we use any of these for confidentiality and for MAC, we have to have keys. The keys that we use for confidentiality are different from the MAC. We have to use different keys altogether. We can't possibly use the same key, by the way. Nothing will stop you. But in all standards, we will see that in all the standards, they tend to use different keys for MAC and different keys for confidentiality. That's highly secure. ماشي؟ طيب. But the result of the authentication process gives you one key, which is the master key, right? So from this master key, you need to generate multiple keys, okay? Minimum 2, one for confidentiality and one for message authentication, right? It's not as easy as this. In fact, we create tons of keys. We'll see what each key is used for. So that's why there is a key generation process as part of the standard. ماشي? So usually what happens is that using the master session key and the MAC of the access point and the MAC of the station and a bunch of other things that we will talk about, sometimes nonce, sometimes other things, ماشي? We have to perform some key generation process, ماشي? That will give us multiple keys, in fact, more than like 5 or 6 keys. Actually, more than 7 keys. Okay? One we can use for confidentiality, one can be used for MAC, for message authentication codes, but we will see that we have a bunch of other keys and why we need each one of them. Okay?
And there's too much overhead.
It is overhead, but this is what the standard recommends because this will increase the security strength of the system. Because remember, in wireless, it's highly volatile. ماشي? It's highly volatile. Anyone can listen to the wireless environment. Okay? Not only that, it's highly dynamic. Some station can pass by. We talked about basic properties that makes really wireless very vulnerable to attacks, right? So because of this, we have to really care about security, very, very high levels of security, even if it introduces some overhead. The same we have done, by the way, when we designed the multi-access techniques. For multi-access techniques, we had to introduce some overhead, but we have to. We just have to, because the wireless environment is really vulnerable, is really dynamic. We have to do this. So the key generation process is really a fairly complicated process as part of 802.11i. So we'll talk about all these keys. So I spent a long time in these 2 slides just to give you the overall picture. So as we said, there are 2 phases for wireless that really distinguishes wireless compared to wired. One of them is discovery/association. ماشي? Discovery/association it involves the fact that first you should sniff all the available Wi-Fi's, right? So it gives you a list of all the Wi-Fi's. So with the name, SSID, with the MAC address of the access point, right? So one station may have choices to connect to any access point in the neighborhood, right? So this is the discovery, and then you have to select either manually or based on certain logic or something that you want to associate yourself to a specific access point. So that's about what triggers the remaining logic. So once we say connect to this access point, we know the MAC address, right? So we know the MAC address from the discovery phase. So we want to say that, okay, so we want to connect to this. Once we connect to this, we have to perform the authentication phase. And this can be done using all the steps or all the options that we talked about. That depends whether you're using we use it null authentication. We call it null authentication. Null authentication means that only with the access point, I want to connect to you, they say yes. He cannot say no. He has no other choice. I don't have anything to provide. I don't know the password. There is no password. We call it null authentication. And again, null authentication is supported in 802.11i for backward compatibility, right? Or WEP, in which case I need to give you the password, but you will generate one pre-shared key for everyone. or I need to give you the password and use WPA, in which case you will generate, yes, a key, but the key is now, it's exclusive to one station. And the access point needs to maintain all the keys for all the stations. Or WPA2, which means you need to do the same thing, but now through the authentication server, using 802.1x and so on, and extensible authentication protocol. So this authentication part is the result here is master session key. From the master session key, I need to do key management, key generation and management. So from the master key, I add other things, ماشي, to generate by a bunch of keys. ماشي? One is used for confidentiality, one is used for MAC, one is used, we'll see, one is used to encrypt some control messages. Very complicated. You will see يعني, the explosion of keys will happen now. ماشي? Only after this step that we will have a protected control port which is now available for communication. ماشي? Before all these phases, the port is controlled, but it's blocked. You cannot use it for communication. And we'll see this. ماشي? Once the port becomes unblocked, which means that it's controlled, and unblocked, which means that the authentication and key management and discovery, of course, all of this is done, then you can use it for communication. Then you can use all the keys to do protected data transfer. Which means that you have all the keys to, not only, by the way, not only unicast, the access point, remember, the access point can perform broadcast or multicast. Okay? So the access point can perform unicast, multicast, broadcast. All of this is under protected data transfer. And then after you finish everything, you do a connection termination, which will trigger the deassociation from the access point. This is the phases that we do for 802.11i. So let's zoom in and dig deeper to see how these phases are conducted. So, as we said, the station, without doing anything, it should see all the available Wi-Fi's. Then it knows the access point MAC address, that it wants to probe. So it sends a request to the MAC address. I want to connect with you. So the MAC address responds back to say, okay, but you need to set up the security parameters. You need to perform authentication. And so this is the part where we do the association. Now we need to perform authentication. So as we will see here, we see 3 or 4 levels, possible levels of authentication. One is using what we call open system authentication request to perform what we call null authentication. Null authentication. I need to connect with you, and I don't have to provide anything. It's just that I know the MAC address, halas, that's done. But we have to send 2 messages for this to account for the authentication fees. ماشي? But I don't have to send any passphrase or send anything. I don't have to perform any, we call it null authentication. ماشي? And this is like a request and a reply, that's it. Or, the second way is that there is an association request. This is done as part of WEP, ماشي? Or WPA. Because in both cases, we have to hereby involve some authentication based only on knowing the password. And this is not based on 802.1x. This does not require 802.1x. ماشي? So option 2 is valid for WEP or WPA. Which again, these are provided as part of 802.11i4. Why? For backward compatibility, yes. تمام كده؟ الناس سرحت. لا ده انت لسه، ده انت اصلا لو سرحت دلوقتي انت حر، يعني لسه اللي جاي. you have to يعني ايه remain focused لان اللي جاي اصعب. اوكي؟ طيب so those two possible authentication methods are provided for backward compatibility. The third بقى one which uses بقى 802.1x اللي هو اللي احنا مسميناه ايه extensible authentication protocol over LANs. But here بقى the port is logical port, of course, not physical port. It's a logical port. And you see it's 802.1x it's done for a control port that's currently blocked. It's a control port, which means that control port معناها authentication is required before the port has to be unblocked and available for communication. Okay? So control port معناها authentication is a prerequisite for communication. ماشي كده؟ ده معناها control port. So the third method is using 802.1x, which requires some EAP requests, اللي هي extensible authentication protocol. And this has to go through radius server. Remember, this is authentication server. This authentication server is a logical entity. It could be implemented as part of the access point, or it could be in the distribution system. It could be done or implemented as part of the distribution system, اللي هو back end system, or it could be implemented inside the access point. ماشي؟ But in all cases, you have to go through that authentication server using بقى اللي هو الراديوس، اللي احنا سميناه radius server. ماشي كده؟ So you have to perform the whole extensible authentication protocol over 802.1x to go through all the way to the authentication server and then come back. And this can take multiple messages back and forth. Okay? طيب. So it depends on the authentication, whether we use IKE or زي ما احنا or TLS or TTLS or whatever. We talked about this in the previous chapter, chapter 4, chapter 5. ماشي? Here, the result here is that we have master session key. We still see the port is controlled and blocked. طب ما احنا عملنا authentication. Why is it still blocked?
Still needs to go the other way.
لا ما هي it went all the way to the authentication server and came back. خلاص, we've done the authentication. And we have the result is a master session key. Why the port is still blocked here? There is a phase that's not in this picture.
Key management.
أيوة. Key generation and management. Because the master session key is a prerequisite, but it's not enough. It's not enough because from this master session key, I need to generate multiple keys. I need many keys. Okay? Because again, the master session key is صح هو exclusive للstation على فكرة. Master session key is exclusive to one station, but is it enough to do confidentiality and MAC and all this stuff? لا. From the master session key, I need to generate a bunch of other keys. ماشي? So here we have to do a key generation and management, which is not in this picture. Next slide. So the key generation and management, the next slide. يعني. Here we talk about the difference between the controlled port and uncontrolled port. Controlled port معناها in this port, whether it's a logical or physical port, ماشي? Control port معناها it's authentication and key management is a prerequisite before you can do data transfer. Okay? طب هتقول لي do I have any other alternative? Yes. The port between the access point and the authentication server, this cannot be a control port because this is actually used to communicate authentication messages with the radius server. So it doesn't make any sense that this port also needs to be authenticated. So we call this port uncontrolled port. But it's part of the distribution system, so it's secured using other methods, not by 802.11i. So the uncontrolled port allows the exchange of protocol data units between the supplicant and the other authentication server, right? Regardless of whether there is an authentication or not. I don't need to do authentication of the access point to the authentication server. That's what it means. Okay?
Controls is me to access and then
Yes.
access to
Yes. Access between the access points and the authentication server in the back end through the distribution system. This is called uncontrolled port. Okay? Because it doesn't have to be authenticated before communication can happen on it. ماشي? But controlled port is between the session and the access point, and this has to happen all the time. This has to be controlled. And it's always blocked until you pass successfully through this discovery, association, authentication, key generation, and management. All of these have to happen before the port becomes unblocked. Okay? So that's what we will see here. ماشي? So we'll talk about this. So until here we said that we performed the so this is the same slide. This is the slide. طيب احنا the result of the authentication process is to have اللي هو ايه master session key. ماشي؟ So you have either pre-shared key for the case of WEP or WPA. From the passphrase, we generate the pre-shared key. That's it. So the pre-shared key is either common for all stations in the case of WEP, or it's exclusive to each station, and in the case of WPA. That's the difference. That's what's called protected access. ماشي؟ طيب. Or master session key. في حالة 802.1x. طيب. From the master session key بقى, we have to generate what we call Pairwise Master Key. And from the Pairwise Master Key, we have to generate Pairwise Transient Key. And this is, in fact, 5 different keys. It's not one key. ماشي? ماشي? We have many of these keys, so we need to know بقى the first question that comes to mind. صح. طب ما احنا we have master session key. Why do we have to have pairwise master key? ما هم master. الاثنين master يعني. So that's the question, the first question that we need to have. We need to answer next time. Okay? So the first question is, from the master session key, why do we need to have pairwise master key تاني? Okay? طيب. I achieved the pairwise master key. Why do I need all these other keys? طب 2 enough.
Pairwise يعني yes.
Pairwise معناها it's pairwise يعني between the access point and one station. ماشي؟ فهي between the access point and one station, but it's master. Master معناها ايه؟ It's available for a longer period of time. ماشي؟ And then you use it to generate other keys which change over time. ماشي? So from the pairwise master key, I would expect to add some nonce, and this nonce is dynamic through time, which will have some variable factor that will generate multiple keys over time. ماشي كده؟ طيب, we know this, and we have done this for WPA. But why do I have to have 7 keys from the pairwise master key? ما هم all I know is that I need to perform confidentiality and MAC. صح? So 2 keys. Why all the other keys بقى? ماشي? That's what we need to answer and talk about next time يعني إن شاء الله. ماشي?